Welcome to Structural Engineering Online. In this video lecture, we will learn how to calculate the support reactions of a simply supported beam. Please subscribe to our channel if you have not yet subscribed, so that in future when we upload any new video lecture, you will be notified and you get the benefit of that video lecture. Thank you very much. In this question, we will calculate the support reactions of a simply supported beam which is subjected to trapezoidal loading. So first of all, we will identify how many reactions are possible on the supports, and for that, if we see that because there is no horizontal loading, so there is no possibility of any horizontal load. So although in normal cases a hinge support will have two reactions, but because there is no horizontal loading, we can say that there will be only one vertical reaction at A. And of course roller will have only one vertical reaction, so total reactions will be equal to just 2. So we show here these reactions, one reaction VA at A and one reaction VB at B. These are the two possible reactions in this case because the loading is totally vertical. Now if you look at the load is trapezoidal loading. This trapezoidal loading we can simplify just by dividing into two parts. So from here, if we draw a line from here, and that will make it a rectangular part and a triangular part. So rectangular part is just like your uniformly distributed load, which we can say that this will have an intensity of 2 kilonewton per meter as UDL. And this triangle is giving you an intensity of 3 kilonewton per meter at its maximum point. So we can say that this load is now divided into two parts. One uniformly distributed load and the other one is triangular load. And you have already solved some problems in the previous lectures how to calculate the reactions when there is uniform load or when there is triangular load. So this is just the question where we will apply the principle of superposition, and we will take these two loads one by one, and then we will apply first our equations of equilibrium, sigma fx equal to 0, and this says that there will be no horizontal reaction. That's why we have not considered here. And when we apply the equilibrium in y direction, we will get VA plus VB because these two are acting in the vertically upward direction. So we write here plus VA plus VB, and then because these two are acting in the vertically upward direction, and upward directions we are taking as positive, downward is negative. So now UDL, which is uniformly distributed load of 2 kilonewton per meter, is acting over a length of 3 meter. So we can say, okay, this is your UDL. So UDL is 3 multiplied by 2. This is the amount because 2 kilonewton per meter over a length of 3 meters. So total is 3 into 2. Then we have this triangular load with the intensity of only 3 here. This is just 3 kilonewton per meter, the difference of 5 minus 2. So for triangular loading, the total load will be equal to half base into the height that is 3 kilonewton per meter and base is 3. So these are the two acting loads. There is no other load acting on this beam. So plus VA plus VB minus 3 into 6 minus half of 3 into 3 is equal to 0. This is your sigma Fy equal to 0. Now we go to the third equation, sigma M about A. We take moment about any point of the beam, and in this case we are taking moment about A. Okay. So here what we get, VB, if you look at VB, how it will try to rotate. This is VB, and VB will try to rotate your beam in the anti-clockwise direction. So anti-clockwise moments are taken as positive. So we'll write here VB into 3, the moment of VB about point A. Then we take the moment of this uniform load, and this uniform load will try to rotate because it is acting downward. And if you look at this load here, any load which is applied in this way, so at this point it will try to rotate in clockwise direction. So clockwise is negative, anti-clockwise is positive. This is our sign convention for the moment. So VB into 3 is positive, but the moment of this UDL is negative. So minus 3 into 2 into, and where is the centroid? To take the moment, we always take the position of the centroid. So distance of the centroid from point A, which is 1.5 meter. So we multiply by 1.5. Now we take the moment of this triangular load. So here we have this triangular load of having maximum intensity of 3 kilonewton per meter at point B. So when we take the moment, it will be minus half into 3 into 3. This is the load. Now we multiply by the distance of its centroid. As we know that the centroid of our triangular load is at a distance of 2/3 of the base, 2/3 of 3 in this case now, because the base of this triangle is 3. So the distance of centroid is at a distance of 2/3 of the base from A. So we see here that this will be 2/3 of 3, and this whole thing equal to 0. Now we can simplify this equation, and we can say that 3VB minus 3 into 2 into 1.5, which is equal to 9, minus 9. Then 3 cancel, this 2 and 2 cancels, minus 3 into 3, 9, equal to 0. So from here we get that 3VB is equal to 18. Therefore VB equal to 18 upon 3, and that is 6. Now we have got the value of VB. We can easily calculate the value of VA by substituting the value of VB in our equation, which is this one, where we get here that this VA plus VB will be equal to, VA plus VB is equal to 6 plus 4.5, that is, okay, so our equation VA plus VB is 10.5, right? From this equation number 1, here we can say that this is equation number 1. So in this equation we substitute the value of VB, that is 6, so we get VA plus 6 equal to 10.5. Therefore VA is 10.5 minus 6 equal to 4.5. So this way we have got the values of these support reactions for a simply supported beam when it is subjected to trapezoidal load. And in this case also you have seen that we have to apply the equations of equilibrium, and we have divided the trapezoidal load into two parts. One part has become a rectangle, so that is treated as a uniformly distributed load, and the other part is considered as a triangle, where the intensity of that maximum intensity of that triangle is difference of the two, as you have seen. We hope that you enjoyed this video lecture and it has helped you in learning how to calculate the support reactions of a simply supported beam. You are also requested to subscribe to our channel and also share this video with your friends so that they can also get the benefit of this video lecture. Thank you very much.